Welcome to the DIY Honda Garage channel. The diagnostic trouble code P0328 is related to the NOx sensor circuit, specifically indicating a high voltage issue. The NOx sensor is crucial for monitoring engine vibrations and detecting engine knocking, which can lead to damage if not addressed. Located near the engine block, it sends signals to the powertrain control module, PCM, to adjust ignition timing for optimal engine performance. A high voltage reading in this circuit means the PCM is receiving a voltage level that exceeds normal parameters, potentially leading to a warning light on the dashboard or degraded engine performance. Understanding this code is essential for maintaining engine health and ensuring smooth operation. The troubleshooting process follows a systematic approach to pinpoint the issue in the NOx sensor or related circuitry. The NOx sensor is an electronic component that detects irregular vibrations or knocking in the engine. It is essential for optimal engine performance as it helps in adjusting ignition timing by sending information to the powertrain control module, PCM. Located on the engine block, its placement is strategic for accurate monitoring. The PCM uses the data from the NOx sensor to determine the best timing for igniting the air-fuel mixture in the engine cylinders. A high-voltage situation in the NOx sensor circuit suggests a fault either in the sensor itself or in the wiring that connects it to the PCM, leading to potential engine knocking that could harm engine components over time. Identifying the exact nature of this problem is crucial to prevent further damage. The first possible cause of DTC P0328 is a faulty NOx sensor itself, which may have internally failed, leading to incorrect voltage readings being sent to the PCM. Another reason could be damaged wiring in the harness connecting the NOx sensor and the PCM, which could cause high resistance or short circuits in the signal path. Additionally, issues with the PCM can result in incorrect fault detection and high voltage readings, as it could misinterpret or fail to process the signals from the NOx sensor adequately. Each of these components plays a vital role in ensuring that the engine runs smoothly and efficiently, and problems in any of them can lead to significant performance issues. Diagnosing the root cause involves a process of elimination. When DTC P0328 is triggered, one of the most noticeable symptoms is the activation of the engine warning light on the dashboard. This warning indicates that there is a potential issue within the engine management system that needs addressing. Additionally, the vehicle may experience poor engine performance, which can manifest as rough idling, reduced acceleration, or stalling, leading to an unsatisfactory driving experience. Increased fuel consumption often occurs because the engine's timing adjustments become compromised, causing inefficiencies in how fuel is burned in the cylinders. Further, if the engine continues to run under these compromised conditions without addressing the issue, it can potentially lead to more severe engine damage long-term. Therefore, early diagnosis and resolution are crucial to begin troubleshooting DTC P0328. First, verify that the vehicle is in the on mode, as this allows the diagnostic system to access relevant data. Next, use the Honda Diagnostics System, HDS, to clear the current DTC. This action resets the onboard computer and can sometimes resolve transient issues. After clearing the DTC, switch the vehicle to the off or lock mode, and then power it back on to the on mode once again. This step is essential as it prepares the system for a fresh diagnostic read. Now, check if any pending or confirmed DTCs appear on the HDS. If DTC P0328 reappears, you will need to proceed to the next troubleshooting step, confirming that the failure is indeed consistent. For troubleshooting step 2, Turn the vehicle back to off mode before continuing. Disconnect the 2P connector associated with the knock sensor to isolate the component for further testing. After disconnection, switch the vehicle back to the on mode without reattaching the connector. Utilizing a multimeter, measure the voltage between the first and second test points located in the knock sensor connector. Test point 1 is at female terminal number 1, and test point 2 is at female terminal number 2 of the knock sensor connector. If the measured voltage is around 5.0 volts, this indicates that the wiring and signal path are functioning correctly, and you may need to replace the knock sensor itself. Conversely, if the voltage is not what is expected, the next step involves checking the sensor line to the PCM for further issues. In step 3, you continue measuring the voltage while keeping the knock sensor 2P connector disconnected, as voltage measurements are critical for diagnosis. Refer back to the same test points. Test point 1 at female terminal number 1 and test point 2 should be connected to the vehicle's body ground. Again, you are looking for approximately 5.0 volts. If the correct voltage is observed, this suggests that the KS line feeding voltage to the sensor is operationally sound. You will then proceed to step 5, focusing on assessing the ground line for any issues. However, if the voltage is insufficient, further investigation into the wiring may be necessary to resolve any potential faults in the circuit that could be causing the high voltage reading. Step 4 involves performing an open wire check on the KS line, which can help identify any breaks in the circuit that could be affecting the knock sensor's functionality. First, ensure that the vehicle is turned off before proceeding to jump the SCS line using the HDS, which essentially initiates the short circuit system and prepares the vehicle for continuity testing. After this, disconnect the PCM connector C, which has 51 pins. Your next assessment involves measuring continuity between test point 1 at the knock sensor connector and test point 2 at pin 29 of the disconnected PCM. If continuity is confirmed, this means the KS wire is intact and functioning well, and you should look for authorized service information based on the DTCs you're troubleshooting. If continuity is not present, further examinations or repairs will be required for the wiring between the PCM and knock sensor. In troubleshooting step 5, the similar approach is taken, but focuses on the KS-GND line, which connects the sensor to the vehicle's ground. Just like in the previous step, start by turning the vehicle to the off mode before jumping the SCS line with the HDS. This prepares the vehicle for another round of continuity testing. Disconnect the same PCM connector C at pin 28 for this check. Measure the continuity again, this time between test point 1 at female terminal number 2 of the knock sensor connector and test point 2 at pin 28 of the PCM connector. A continuity check that confirms a good connection indicates that the KS-GND wire is functional as well. If both wires have continuity, your diagnostic effort should include consulting authorized service information related to the DTCs. However, if there is no continuity between the KS-GND line, it's imperative to repair the wiring connecting the PCM and knock sensor to restore function. Once repairs or replacements have been made, final verification is critical for ensuring that the issue associated with DTC P0328 has been resolved correctly. Begin this verification by clearing the DTC with the Auto Diagnostics system, HDS, which resets the onboard computer system. After clearing, take the vehicle for a test drive, which allows the engine to operate under normal conditions while monitoring its performance. During this drive, carefully observe for any symptoms of engine knocking or check engine lights returning. If the symptoms do not reappear, it is a strong indication that the repairs effectively address the problem. However, if the issues persist, it may require a deeper analysis of other related components or systems to ensure accurate diagnosis and resolution. To prevent issues related to DTC P0328 from occurring again, implementing regular maintenance practices is essential. Start by including routine inspections of the wiring harness connecting the knock sensor and PCM, ensuring there are no signs of wear, fraying, or loose connections that could create electrical faults. Additionally, periodically check the knock sensor's function as part of the vehicle's overall diagnostic checks. Integrating it into the regular service intervals. Proper engine tuning can also help in preventing issues, as a well-tuned engine operates within optimal parameters, reducing strain on the knock sensor and other components. Lastly, keeping an eye on any warning lights or engine performance changes can allow for proactive measures before faults develop into more significant issues, ensuring the longevity and reliability of the engine system. In summary, understanding the role and function of the knock sensor is vital when addressing DTC P0328. The step-by-step troubleshooting process allows for a precise diagnosis, ensuring that technicians can identify and resolve high-voltage issues effectively. It's also essential to recognize the potential causes of such failures, including faulty sensors and wiring issues, which underlines the importance of thorough inspections. Implementing preventive maintenance can help mitigate risks of recurrence, emphasizing the need for regular checks on critical components like wiring and sensors. Overall, attention to detail in both diagnostic and repair processes will enhance the vehicle's performance and reliability, ensuring a smoother driving experience for the Honda CRV owners. Please like and subscribe to the channel. See you next time.